Hello. Right, we're on to, 23 or 24. So what we've got is ABC is transformed to A dash B dash C dash by a reflection in the line x equals 1. Now, if I make this mistake, you probably will too. My issue is that I often make it x or y equals 1, but in this case, y equals 1 would actually be on the BC line. So draw in x equals 1 there, okay. Now reflect through it, so we'll go C goes 1, 2, 1, 2, so that's C there, and then B goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and that makes sense, that's B, and then A is going to be straight above that one. So this is A dash B dash C dash. Now that bit I can do. The next bit is going to go horribly wrong. So A dash B dash C dash is transformed to this, A, B, C with the double dashes, by a rotation 90 degrees clockwise around 1 minus 4. So 1 minus 4 is here. So it's 1 minus 4. So you're doing it round here. So what you need to do is you need to take a piece of tracing paper, which I may or may not have around me. No, that is very much a book. So take a piece of tracing paper and then use it to trace. I had to do this with one of my students the other day. And this, you can't see me do this though. So I'm now going to lay this on and I'm going to draw that on, and then you go literally round, and that takes you round 90 anti-clockwise, takes you, that way. Hang on. So if that's there, that's there. So it takes you, not entirely sure I've done that properly. Basically, I can't really do this. And then you've got to get it, what ABC is invariant under the combined transfer, which one point. So invariant means that something is going to be touching it. And I think it might be that point there, might have B on it, but I could be wrong. And I don't necessarily know that I'm right. So I think it might be like that. And then you would say B. And that's how you do that. Sorry about that. Now, solve x squared minus 5x minus 6 is less than 0. So what we do here is this. We do exactly what we would do normally when we solve x squared minus 5x minus 6 equals 0. So let's imagine that we can factorize this. So something that times is to minus 6 and adds to make minus 5. So that's going to be minus 3 and is it? So it's going to be minus 6 and plus 1. Because minus 3 and minus 2 would not give us, they would give us plus 6. So it's going to be x minus 6 and x plus 1 is going to give us what we need to, and that's going to be less than 0. Now, if x plus 1 equals 0, that means that x equals minus 1. And if x minus 6 equals 0, that means x equals 6. So if we did a little drawing of this, we've got x is minus 1 and x is 6. Then we draw this through like that. Now, sorry, that's meant to be 6. So this now means it's all the space under here that is what we consider. So when x is between 6 and minus 1, that is when it is under 0. So when you draw that map, that's what you're trying to do. And if we're going to do that on a number line, we get it's between this one and that one. Personally, I find it easier to do it on an actual quadratic, though.